We've all been told the Earth is big. Bigger than any of us could possibly imagine. But what is the actual size of the Earth, or circumference? Obviously, there must be a more practical way of measuring it without taking a tape measure and measuring the whole world. In fact, there is a way, and that is what we will be discussing today. Now, we're to be starting at the very beginning, which just happens to be in Libya. And by beginning, I mean going back in time, all the way to the days of 276 BC, when a child, who would later discover just how big this world is, was born. His name was Eratosthenes. When Eratosthenes grew up, he became the third librarian at the Great Library of Alexandria, and made many contributions to the world of science, though he is most famously known for calculating the Earth's circumference with amazing accuracy. Eratosthenes was first introduced to the question of how big the Earth was when a friend of his, who lived many miles south of him in the town of Swinnet, sent him a letter telling him of how at noon, on the solstice, he looked down into a well and saw his reflection, and he also noticed that his head was directly blocking the sun. This intrigued Eratosthenes. He knew that the city of Swinnet just happened to be on the Tropic of Cancer, and that the sun was directly above it. Now, knowing the Earth was round, he knew that if he placed his stick in the ground all the way in Alexandria, on the same day, the solstice, at the same time, at noon, it would cast a shadow that he discovered was 7.2 degrees off axis. So Eratosthenes used math to figure out the circumference of the Earth. Yes, this was his brilliant discovery. He knew a circle is 360 degrees all the way around, and if you have 2 points on that circle, then you need to know 2 pieces of information. The distance between those 2 points, and the angle formed when a line is drawn from each of those points to the center of the circle. The angle was 7.2 degrees, so now he needed to know the distance between his 2 points, which were in Swinnet and Alexandria. And at the time, the road going between these 2 places was a popular one for commerce, so he also knew that it was 500 miles. He divided 360 by 7.2, and that equaled 50. He then multiplied 500 times 50 and got 25,000, which is within 1% of the actual circumference. And so, for an experiment, I decided I would attempt to mirror Eratosthenes and what he did, except with a few alterations. I hypothesized that I could measure the circumference of the Earth myself and be within 10% of the actual circumference. And to perform this experiment, I would need 2 yardsticks, 2 boxes of Play-Doh, paper, the time in which the sun was at its highest, and a location at least 30 miles north of the lab. And so I rounded up my enthusiastic lab assistants and gave them assignments. Since I would need to measure the shadows of the sticks like Eratosthenes in 2 different places on the Earth at the same time, 2 people would stay at the lab and do the experiment, and 2 others would drive north 30 miles and stop wherever that was and do it there too. So naturally, we found ourselves behind a Home Depot parking lot in Windsor. We began setting up our experiment. First, we placed the yardstick upright on the ground and used the Play-Doh to hold it up and make it stay. We then looked at the shadow the stick was casting and laid a piece of paper down on the ground so that the shadow now fell on the piece of paper. 10 minutes before local noon, which was when the sun was at the highest it could be at that time of year, we started to mark the tip of the shadow every 2 minutes. The shadow got shorter and shorter, ever so slightly, until all of a sudden it began to get longer and longer, which meant we could stop measuring since the exact local noon had passed. We picked the shortest marking out of all of them and used it in our calculations. The length was 54.5 inches. Meanwhile, back at the lab, my dedicated associates labored with the same process. Their results were 53.5 inches. Next, there was an hour of darkness, in which the math wasn't making sense, and the Earth's circumference was murky. At one point, the Earth's circumference came out negative, and at another, we were 75% incorrect. And then we finally realized our mistake. We hadn't converted our measurements out of inches and into centimeters yet. So here's what we figured out. We found 2 angles. Now, what we're looking for is this 3rd angle. We subtracted one from the other and found the mystery angle, 0.506 degrees. Next, we found the second piece of information needed, the north-south distance between the 2 locations, Windsor and the lab. The distance was 71.56 kilometers. We then followed in Eratosthenes' steps and divided 360 by the mystery angle 0.506, getting 711.46, and multiplying that by the distance, 71.56 kilometers. And our circumference of the Earth turned out to be 50,902 kilometers. The actual circumference measured by the scientists of today is 40,075 kilometers. So we were about 27% inaccurate. In conclusion, my hypothesis was wrong. Turns out I could not measure the Earth's circumference within 10%, but the world is a big place, and we are only a small part of it. Even we can make a difference, though. Just look at Eratosthenes. He truly is an inspiration to all, even to this day.